All right, hi everybody. What we are doing today is we are starting Chapter 8, Section 1, right triangles and trigonometry. So Chapter 8 introduces... Thank you. Chapter 8 introduces trigonometry. It will be introduced in the way that we normally think about it, probably in Section 3, but the first couple sections sort of lay the groundwork for it. They bring us from where we have been to where we are right now. For those of us who don't know or who think that the word trigonometry sounds scary, I just told you what it actually means. It comes from two Greek words, trigon, which means triangle, and metri, which means measure. So what we're really doing is just measuring triangles. Okay? It's a little more complicated than that, but that's all that trigonometry means. Okay? We're going to use angles and lengths of triangle sides to find missing information. All right? Today we are going to talk about geometric mean. Has anyone ever heard of geometric mean before?
No.
I think.
Are you sure? Because until a couple of weeks ago, I had not heard of geometric mean.
It sounds like something I've heard.
I think I was introduced as well. I was like
All right.
some paper.
So, geometric mean is another kind of average. We have talked about, or in your math classes, you have talked about mean, you have talked about median. These are both kinds of averages. Geometric mean is another way to kind of think about how to find something that's sort of in the middle. It's done a little bit differently, and it comes down to this diagram right here. Okay? The A over X equals X over B. Just a simple proportion, and this defines geometric mean for us. Okay? So let's go through the words, and then using the actual example, I think it'll make a lot of sense to you.
You want to write all of that down?
Yeah, you'll have to write this key concept down. So in words, the geometric mean of two positive numbers, A and B, is the number X that makes this true, such that A over X equals X over B. So to find the geometric mean between A and B, we have to find the number X that makes this true. Okay? So, what that means is that if we do our cross products, X squared is going to equal AB. And so to find, how would you solve this equation for X right here? If X squared equals AB, then what does X equal to? Ayala.
So wouldn't you go X squared for both A and B, and then you multiply it, and then you do like X?
No, I want to solve not for X squared, I want to solve for X.
Oh, for X, then find the square root.
Find the square root, that's it. So really to find the geometric mean between two numbers, all we're going to do is multiply them together, A times B, and then take the square root of them. It's that simple.
Wait, so it's the second equation, or it's both of them?
This is all ways to rewrite the same thing. We start here, we do the cross products, so we get X squared equals A plus B, and then finally we wind up with that, X equals the square root of A times B. Okay? So, how would you find what would the geometric mean of A and B be if A is 9 and B is 4?
Square root of 36.
Square root of 36? Exactly right. It's equal to 6 because you take the two numbers, you multiply them together, 9 times 4, and then you take the square root. Just that simple. Okay, you now know a new way to do average. And remember, if you have trouble remembering what gets multiplied by what, think about this diagram right here. This tells everything you need to know about finding geometric mean. If you're trying to find the geometric mean between A and B, they go on what's called the extremes, the top left and the bottom right, and then the number X, which will be the mean, is going to go in the middle, and you just do your cross products and solve for it. Okay? All right. So moving on. Which of these, I put up 4 different proportions. We're going to circle a couple of them. Which of these are going to represent geometric mean, and which of them do not? When you tell me something that does not, you got to tell me why. Okay?
Can I say which ones do not first?
You can tell me one.
Okay.
Which one would you like to tell me?
The x over x equals x over x.
X over x equals x over x. Is that a geometric mean or not?
No. No.
No.
Okay.
You have 4 x's, but you don't know the values.
Say it again.
A over B.
No, the
No.
This one? Why is this one not?
Because it doesn't have two of the same.
Yeah, it doesn't have 2 of the same, so you know it's automatically not. All right? Let's see. This is actually great. So,
No, the first one is wrong too.
thank you.
Because
Why is this one wrong?
Because you're supposed to put the A and B on the outside.
Well, yeah, so the 2 different numbers are supposed to be on the outsides. And really, the reason that this one is totally wrong is this and this are not the same.
Oh.
Those have to be the same because that's supposed to be your geometric mean. This is not correct. This one right here.
That one's correct. No, that one's wrong too. No, that one's right, that one's right. No, wait, is it?
It's
I-
right.
I do suppose this one.
Yeah, that's right.
Because if we do C over A equals A over B,
It would be right.
it's the same thing.
Yeah, but
C over
it's
A.
not fun. It's A over X. it's
Yeah,
not X over
you know
B.
what? This one I should not have included. This is you're right about this one. This one would work, but the one that I tried to confuse you guys on, I managed to. There's one of these that is correct that we have marked wrong.
The XXX. Right. Yeah. See,
This one right here.
I'm right. Oh.
Everybody look at this one.
I'm so confused.
Let's do our cross products.
The only way I can say it is because both, like, it'll equal the same thing.
X squared equals x times x, right?
X squared.
And if I want to solve for x, x is equal
The
to
square root of X times X.
the square root of x times x,
Which is X.
which is of course x. So what this is saying is if you had
And
2
we can
numbers,
equals one.
basically, yeah, if you have 2 numbers that are the same, what is their geometric mean?
The same.
The same. And that should make sense, right? Because if you had 2 numbers, 100 and 100, what's their average? 100. So this is another kind of average. If you start with the same number twice, you should have their geometric mean be the same. Okay? So this is going to be x equals x. So that's a silly example. This one, and this one are both right, and this one is wrong altogether. Okay? So, find the geometric mean between 8 and 10. This should only take a couple of seconds.
Oh, you want us to write it down?
Yeah. You don't have to write all the words, but find the geometric mean between 8 and 10. Okay? Can you simplify that, though? Because we need to practice our simplifying radicals.
Wait, yeah.
Which one's A and which one's B?
It doesn't matter.
Oh,
Because you're multiplying them together. You can do A times B or B times A.
With 8 times 10. That'll be 4 square root of 5.
Not exactly.
I don't know. Whatever the square root of 80 is, that's your answer. That's
All right.
Your answer.
So, most of us are realizing...
Square root of 80.
So, we start...
4 square root of
Okay, well, maybe you're right. We'll do square root of 8 times b, which is square root of 8 times 10, which everybody here is telling me is the square root of 80, right? Then we're going to factor it. 8 is 4 times 2. 10 is 2 times 5. And what is 4 times 2 times 2?
So basically, you have to factor it.
Yeah,
16.
it's 16. Yeah, we need to factor it so that we can simplify. You see how we rewrote this as 16 times 5?
Yeah.
Why would you do 4 times 2 times 2?
Okay.
Wait, so
We want to rearrange the factors so we have a perfect square.
4 times 2 is not 16.
4 times 2, no.
Two.
4 times 2 times 2 is 16.
Why would it be 5 times 16?
So 8, we broke down 8 into 4 times 2, and then we broke down 10 into 2 times 5. We took its factors. And then we tried to multiply these guys together to get a perfect square. 4 times 2 times 2 is 16, right?
That's dumb. How is anybody gonna know that? So stupid.
Yeah, but these are all multiplied. When you multiply a bunch of stuff together, you don't need the brackets. Okay? So we're pulling them out from the parentheses.
But that doesn't make sense. Why would you multiply 2 twice if you're multiplying whatever 4 times 2 is times 2 times 5? That you're gonna get it to completely
It's the
different
square
answers.
root of
Whatever.
Yeah, so 4 times 2 does equal 8, right?
Yeah.
And 2 times 5 does equal 10.
Yes.
Okay, so I can rewrite the square root of 8 times 10 as the square root of 4 times 2 times the square root of 2 times 5.
But I'm not gonna know that.
Well, you know what the factors of 8 are. You know what the factors of 10 are. So you just have to rewrite them as their factors.
Well, how do you know to multiply 4 times 2 times 2?
Because we're looking for something that will give us a perfect square. We don't have a lot of choices. We've got 4, 9, 16, 25, 36. We need to get to some of those numbers if we're going to simplify this. Because here's what's coming. The next part is we take the square root of 16, which is 4, and the square root of 5, which is 5. And once again, Shannon is very smart. Okay, geometric mean between 8 and 10 is what then?
4 square root of 5.
4 square root of 5. Or about 8.9. How did you know this is about 8.9?
Because 9 times 9 is 81.
9 times 9 is 81. We started with square root of 80, so it's going to be very close to the square root to 9. Okay? On your own, try 1a and 1b, and try to simplify them. Welcome back to our video listening audience. We paused it to do questions 1a and 1b. Okay? So, 1a, we want the geometric mean of 5 and 45. So what we're going to do is the square root of 5 times 45. What is the square root of 5 times 45?
Square root of 225.
That's the square root of 225, and that is a perfect square. The square root of 225 is
15.
15, and so that is our geometric mean. Shannon has graciously volunteered to do 1b.
1b is easy.
Talk loud for the video.
Alright, so 12 times 15. The square root of that. I simplified it, which is 4 times 3 times 5 times 3. You take out both 3's and get 4 times 5. And since 4 is a perfect square, you take that out. And you get 6 times the square root of 5.
Excellent.
I do not understand a word she just said.
Okay, so here's
You just said a whole bunch of stuff.
All right.
I can't.
so she basically she breaks this all down to its factors. Okay, she's got 12 is inside here. We've got 12, which is 3 times 4, and then 4 she sees as a perfect square, and so she breaks that down even more. She's got 3 times 2 times 2. In addition to that, 15 is 3 times 5. So 4 times 2 times 2 times 3 times 5. Now here's the thing about square roots. Anytime you have a factor repeated twice inside of a square root, that's 3 times 3, and then you take the square root of it, so it just becomes 3. Or, I'm sorry, 3 times 3 is 9, and the square root of that is 3. So anytime you have a pair of numbers inside of here, you just cross them both out and bring them outside. 3 times the square root of 2 times 2 times 5. And then once again, we have a pair of numbers, right? So the 2 times 2 will be 4. Square root of 4 is just 2, so we'll cross those out and bring them outside. So we have 2 times 3, which is 6, times the square root of 5, just as Shannon has said. Okay? Now what we are going to do we're going to see how this possibly helps us any. We have three theorems today. Okay? Number one, the altitude of a triangle. Anybody remember what an altitude is?
The middle.
It goes the line that goes down, and it touches. It goes from one vertex and it touches the other line at a 90-degree angle. Okay, so this right here, CD, is an altitude.
And that we consider a bisection too.
It doesn't bisect anything though. Bisect means cut in half. It doesn't cut the angle in half, and it does not cut the line in half. Okay. Okay. So here's what theorem 8.1 says: the altitude drawn to a hypotenuse. So big part of it right now. This has to be the hypotenuse. Okay. It doesn't work if we're drawing a different altitude. So if we draw an altitude to a hypotenuse, then the two triangles, triangle 1 and triangle 2, are going to be similar to the big triangle. Okay? So triangle 1, ACD, is going to be similar to triangle 2, and that is both of those are going to be similar to the third one. But the question is, in what order? Okay. Triangle ABC, we have CD as the altitude and hypotenuse AB. First thing I know is that triangle ACD is similar to what?
Triangle CBD.
CBD. Are you sure you did it in the right order?
Or CDB.
Whenever I have a right triangle and I drop an altitude, I create two similar triangles. And they are both similar to the big triangle itself, too.
Well, you know CBA is similar to CBD, or...
Let's see. What I'm starting with is ACD. So which one is going to be similar to that? ACD. D. No, because D is the right angle. We ended with the right angle here.
BCD.
BCD, I might believe that. No, actually, we're going for the big one first. So ABC, we need to end with the right angle. So it's going to be ACD is similar to ABC. Let's see. Let's start off the second one. Okay, CBD. Which one is going to? When we're talking about the big triangle here, how would I align? How would I change it to be?
We turn the red one around, facing the same direction as CBD.
Yeah. So what? When I'm talking about triangle ABC, how do I write it so that it is similar to CBD? CBD. We need to finish at the right angle. Okay, so we need to finish with C, and we start CBD. We start with the long side, the hypotenuse, and finish with the right angle. CAB? Nope. ABC again. Okay, so, well, let's look at it. If we have... Okay. If we have triangle CBD, that's this one right here. Boom, boom, and then back up. CBD. Okay? And then notice I started with my right angle. I went down the short side, then down the hypotenuse, and then back, or I'm sorry, CBD. I started on the hypotenuse, then went to the right angle, then went back up. So in here I need to start on the hypotenuse, then hit the right angle, and back up. So A.
You said at the bottom of the hypotenuse.
Did they make a mistake here?
Probably. I thought it would be CAB.
Let's see. Here's what I always do. When I get confused with this, I'm actually going to rewrite the triangle. CBD. So I'm going to
But they have CBD already there.
C, B, D. And then I'm going to try to turn ABC around so that it matches. So my right angle has to be right here. So it's going to look... Tell me what letters I would put? What's going up at the top?
See?
C.
Mm-mm.
No?
For the big one.
Oh, you. Well, I know what you did. Okay. It'd be A,
A is at the top. Yep.
Oh.
B.
Big one.
The
AD.
corner.
Right at the 90-degree angle. What is that?
D.
See?
C.
Would that be B?
We're talking about the big
Oh,
triangle.
Okay.
So that's
Then
A,
will be
C.
Yeah, that's what I'm saying. B goes in there.
Okay, so if they said triangle CBD, then it should be A, B, C.
Okay.
See, they didn't make a mistake. So really, part of figuring out when triangles are similar but they're not in the same orientation, you need to try to move them around so that they're all facing the same way, which we have done before. Okay? And then finally, the two small triangles, these two, CAD and CDB, are going to be similar to each other. I'll give you the first one. You got to tell me what the second one is. If ACD is what they give you first, how do you say what it's similar to?
BCD.
No. CDB.
C.
CDB.
What is it? ACD. So
CDB.
Well, they're not facing the same direction.
okay. So let's change them. Let's change them. There's no problem with that.
Oh, ABC.
So what is this? What's this point going to be here?
C.
C. What's this going to be?
D.
D.
B.
B. So if they said triangle ACD, then what?
D.
CBD?
That's what I said.
Let's see. Let's see if that's right.
Yep,
There you
that
go.
was right.
You see how easy it is once you reorient them so they're facing the same way?
Oh,
Okay? Good. So, we're going to write a similarity statement for the three right triangles in the figure. They're all similar to each other. We have F, J, H, and G. We want to separate them, reorder them, and then write what's similar to what. Okay? So the first thing we do, we're going to start with FGH, which was our really big triangle. That's this one right here.
so they just
And we draw it right over here. And we just leave it exactly the way it was. Okay?
Cool.
Now what I want to do is I want to take my slightly smaller one, J, G, H, and I want to turn that, if necessary, so that it's facing the same way. Well, the thing is, where is the right angle there? At J. So I need to flip it around. I need to flip that around so that J is at the bottom, which puts G at the top here, and H over on the
But
side.
I thought G had the right angle.
G has the right angle for the big triangle here, but when we're talking about this smaller triangle right here, notice your right angle's now up here. Okay? And then finally the tiny one, where is the right angle going to be for the tiny one?
Can you see it?
J.
J.
Back at J again, okay? Because this makes a right angle. Okay? And so we need to move that so that J is going to be on the bottom. So we first need to flip it that way and then flip it that way, if you can think about it in your head, so that J comes down here. The point is going to be at G and F. A lot of times it's easy to think about, well, where's my right angle and where's my hypotenuse? Or where's my right angle and where's my point? Okay? And try to relabel them that way. So now that we have done that, is this the simplest thing in the world to write the
Yes.
similarity statement for?
Yes.
No.
Naomi, would you like to do it?
Okay.
So by theorem 8.1, triangle, they give you the first one.
F, G,
F?
H.
FJG is similar to?
G, J, H. Right?
Is similar to GJH? Is similar to?
F, G, H.
FGH. See how simple that is? Okay.
Because they're all like that in order. They're not.
Well, yeah,
It's
but-
not like it's flip two different ways. It's simple. That's easy.
Yes, it is. Our job is to flip them so that they're all facing the same way for number 2A and 2B. Once you flip 2A and 2B so that all three triangles are facing the same way, it's very easy to write a similarity statement, and that is our job right now. Welcome back, everybody on video. I forgot to start the video 30 seconds ago when we started going over this, but right now we are drawing the 3 triangles for 2A, and we started with the big one, putting the right angle in the bottom left. And clearly, that's not what I meant to do. Okay. I want to move all of this over here. And now I'm going to draw a second one. I'm going to draw my slightly smaller one, my middle triangle. I don't have a choice about how I'm going to draw it. I have to draw it this way, and it's very, very easy to draw the right angle. I know that for this one, the right angle has to be what letter?
P.
The right angle has to be P. And in fact, for the other one, the smaller one, the right angle has to be P again. Okay? Now, the question is, which one of these is the longer leg? Okay? Which one is the longer leg? Because the longer leg is drawn on the bottom here. So for the big one here, the longer leg was ML. For this smaller triangle, PLM, okay? LM is actually this right here is your hypotenuse, so we're left with legs of this one and this one. Which leg is longer?
PL.
It looks like PL, so we're going to draw the longer leg on the bottom, just like we drew the longer leg here. And this one's tough to see. On 2B, it's going to be easier. Okay? And that leaves us only one choice for the top. What is it? M.
Mr. Duncan,
Mhm.
you told me I was wrong.
Watch this. And then for our smaller one, we have a hypotenuse. What is our hypotenuse for the small triangle?
M.
Hypotenuse has 2 letters.
The small one? Okay.
MK.
Whatever, MK, that's what I meant.
Yep. So that's your hypotenuse. Which one is the longer leg? We've got legs KP and PM.
PM.
PM has to be the longer one. So I'm going to draw M down here, and that has to be
K.
K left up here. So it's the way that I do it is I look for the right angle, I put them in the same spot, and then try to draw the longer leg on the bottom. Did you get the same similarity statement? Because here's what we're going to get for a similarity statement.
I got
Because this is our whole point, is doing this. We want to say that triangle
MKL
MKL
is with the triangle.
is similar to triangle PML.
No.
It didn't save, did it? Oh my god.
Who?
I just got it.
Bad.
I just got it right now.
Not bad.
Ooh, Mr. D, you got saved.
Recording still.
Hey, and it still looks like it's recording. So, welcome back, everybody. If there was an interruption. So we had this was similar to triangle PML, and all of that was similar at this point to triangle
PKM.
PKM. And that's the whole point of what we're doing. As long as you have the first ones that line up with each other, the second ones that line up with each other, and the third ones that are in the same spot as each other, then you have it correct. Even if you wrote something like this, triangle KLM is similar to triangle MLP is similar to triangle KMP. And there's another way to do it as well.
Yeah, I got
Okay.
MPK, MPL, KML.
MPK, LMK, LPM. Okay, you're great. All right, now for 2B, I'm going to take all of this.
Yeah, I didn't even B yet.
I'm going to take all of this. I'm going to put it together. I'm going to shrink it way down. And then I'm going to do 2B. And 2b is a little bit easier because it's very easy to see which are our short legs and which are our long legs. So for the big triangle itself, I'm actually going to keep their orientation. For the big triangle, I have R, S, and Q, with S as my right angle. Now I'm going to do my smaller one, my medium one, that is. And I know that my right angle has to be what? T. And I want to put down here, I want the other side of my short leg. What is my short leg?
R, S, right?
Well, think about, this is the medium triangle. We're talking about this one right here now.
Oh,
So what's my short leg?
Oh, the short leg is the...
ST.
Is ST. So if my short leg's going to go on the side here, then down here has to be S. And then this has to be
Q.
Q. See how easy that is once the legs are easier to see? Okay, and then finally, our tiny one.
So it doesn't matter how you...
How we draw them? As long as they're all in the same orientation.
Yeah, right, they're different.
That's fine. As long as you get the same answer at the end. What is this one right here? This right angle?
T.
It's still T. This one has to be, for the short leg,
R.
R. And so this has to be S. And notice, when you are, here's something very important to remember, everybody. When you're breaking these apart, when you start with three triangles inside of each other, when two of the triangles are going to have the same right angle, they cannot have the same letter in the same spot here. They'll both have an S, but the S cannot be in the same spot. Okay? Otherwise, you've done something wrong. So let's do our similarity statement real quick, and let's go on.
Triangle.
Triangle, let's start with the red one.
STR
STR,
equals
Is similar
similar to
to TS.
triangle QTS, cuties.
is similar to triangle QSR.
It's similar to triangle QSR. Not too hard, right?
The first one was hard.
The first one was hard because it's hard to see which one's longer. I couldn't tell myself. Okay? Okay, so that's that. And as long as you have the same position, or as long as you have S, Q, and Q lined up in the same spot, as long as you have T, T, and S lined up, and as long as you have R, S, and R lined up, it doesn't matter whether you started this one STR, or whether you started TRS, or whether you did TSR. There's a few different ways you could have done that. Okay? As long as they're lined up. Got it? Can we
Yep.
move on?
Yep.
Good. All right. Now, let's talk about similarity. Remember, similarity has to do with ratios of side lengths. So let's come up with our three ratios for these three triangles we just talked about. Notice they are all labeled for you. We start with this big triangle up here. Okay? We start with that one, and then they're all each smaller triangle is labeled for you with side lengths. And I want to talk about the ratios that we get because we know these are similar. Okay? So, let's talk about the ratio of the shorter leg to the longer leg.
This is like confusing me.
Okay? Well, I think it'll become a little bit clearer. Let's do this one. What's the shorter leg on triangle ABC?
B.
The shorter leg is B, yes. And what's the longer leg?
C.
Nope, that's the hypotenuse.
A.
Oh. A. Yeah.
A.
A.
B over A. Now let's go down to this triangle here.
So basically,
What is this side length going to be right here, between D and A? What is that?
between D and A.
D and A. Use this master picture at the top as a guide.
B.
X.
You know what I'm going to do? I'm going to just make our screen a little bit bigger. Okay? So this is going to be X. You are right. What is DC going to be?
I can't
H.
see. Oh.
That's going to be H.
AC is gonna be B.
But I just.
Yeah. All right. Just have to rearrange or reorient. Just a second.
That was so
All right. So this one's going to be H, and then AC is what? Is what?
No, it's gonna be X.
B.
X.
It's B. Between A and C is B.
So
Okay?
basically, you're taking all the triangles apart and making them proportional to each other.
Yes, we're gonna make the proportions explicit too, because we're gonna see something pretty cool about geometric mean right here, and it's gonna lead to two new theorems.
It's not.
Oh, that's
Okay,
not cool.
what's DC?
DC
Is H. DB is
I.
Y, and CB
A.
is A. Now that we have all these labeled, let's do I'm going to do this. This is going to be my green. This is going to be my red. And this is going to be my blue, just so I can keep this color coded. Okay. Now, for the green triangle, we had B over A for shorter leg to longer leg. What is my red triangle going to be for the same shorter leg to longer leg?
C?
X.
What is it?
X over 8.
X over H. Shorter over longer. Yep.
It's in longer. B. B is longer than H.
Yep.
So it should be X over B.
What?
It should be X over B. B is longer than H.
B is the hypotenuse. We're leaving the hypotenuse out because that's just the way I'm setting it up. Okay? And then let's do the same thing. This equals what? H over Y. And then I want to use the magic pen so that I can do something. What do you notice?
H cancels.
Oh, that's the same. 8.1, right?
8.1.
No?
That's the fine.
The thing that you were showing us earlier.
Say it. Say it. Lonnie, you got it.
Geometric mean.
Geometric mean. What is the geometric mean?
H squared. Well, H squared.
H is the geometric mean of x and y. So H is equal to the square root of x times y. This is going to come into our theorem in just a second.
Let's write all that down.
Yeah.
We have to draw those pictures too?
Not a bad idea.
Damn, this is please.
Yeah, I'm not doing it.
Killing me right now.
Okay, and as I suspected, one of these are both wrong. This should be hypotenuse over shorter leg. And this is going to be hypotenuse over longer leg.
So we will have that.
Okay. So I'm sorry, I don't know how I made that mistake, but that was totally my mistake. Now we're going to come up with ratios for hypotenuse over shorter leg and hypotenuse over longer leg. And if for those of us who have seen trig already in physics, you might start to realize that some of these ratios are trigonometric ratios, but we're not going to say that explicitly for a couple more lessons. Now, hypotenuse over shorter leg, what is this?
B over 8.
B over,
H.
Isn't it hypotenuse?
the hypotenuse is not B.
H over
You
B.
said it was.
Hypotenuse for the green triangle is what?
Oh, for the green.
A. For the green is C.
C over the shorter leg.
B.
C over B. And that's going to equal, for red triangle,
B over 8.
B over no.
B
H
over
over
X.
H over H over X.
B over
X.
X.
So hypotenuse is the bottom.
And this is equal to?
A over Y. A over Y.
Y is longer than 8.
It says longer leg.
No,
A.
hypotenuse over short.
A over, over short.
What are you? No.
Hypotenuse divided by short.
So
You
about the
want the
third
blue
one.
one, right?
Yeah, so A is the hypotenuse and the short leg for the
No, the third one is longer.
is
like,
H.
The third one is longer. Like.
H is not longer than Y.
No, it's not. It's hypotenuse divided by shorter leg.
But it says hypotenuse over longer leg.
Yeah, hypotenuse is the A. Oh yeah, this is for
And
the
we're doing the
left.
blue one, right?
We're doing
Both blue.
She's confused because you changed it for that.
yeah, sorry.
Oh.
Hypotenuse divided by shorter leg. Hypotenuse divided by longer leg.
So the longer leg is what?
Okay, so does anybody see a geometric mean in here anywhere?
No.
No?
Oh yeah, the CB over B over
BB.
the B.
So this one over here, it was right here.
The B.
And here we've got the b. So the b is the geometric mean of what?
Yeah.
C and x. So b is equal to the square root
C times X.
of c times x. Okay? And then finally, hypotenuse over longer leg.
So
Let's
it's A.
hypotenuse is, it's going to be this, we're going to start with the same CBA. So C over, what's the longer leg
At Y.
for the green triangle?
Oh.
A.
A. C over A
I'm not.
equals,
B over H.
hypotenuse is B
Over H.
over H, yes?
Equals A
A
over
over
Y.
H.
Equals
Y. A over Y.
A over Y. Now, can anyone, this one's a little trickier, can anyone find the geometric mean here?
Yes. No, no.
There is
actually,
none.
no,
You
no,
can
no.
do C over A equals A over Y.
Let's think of that.
Yeah, that's hard.
Yep. You see that? C,
Oh,
or the A's are there, so A is the geometric mean of
C.
CY.
Y.
Now, does any of this actually mean anything to us yet?
Oh.
It's about to. Okay, here are our two triangles. Because I'm going to put them back, I put all of these letters back. Here's our first theorem. Okay, when we have a triangle like we've been talking about, where you have a right triangle and you drop a altitude from the right angle, okay, then you know that H is the geometric mean. H is going to be the geometric mean of xy, which is just what we found out in the last slide.
What's the definition of altitude in this thing?
Altitude means we drop it from a vertex, and for this case it has to be from the right angle vertex, and it has to make a 90-degree angle here.
So now it can be from any vertex?
No, it has to be from the right angle. Okay? Okay. So, that's our first theorem, and it's pretty simple. Your h, when you have this altitude, is equal to the geometric mean of x and y. So x times y square root is going to give you h. That's a simple theorem, right? Now this one, 8.3, is just slightly more complicated, but not like a lot more complicated. Okay?
There's so many theorems.
Yes, there are lots of theorems. Okay, so for this one, once again, we have the same setup where CD is our altitude. And now let's look at what geometric mean we're talking about. We know that B, this guy right over here, is going to be the geometric mean of X and C.
In the radical.
What?
Right?
B is the geometric mean of X and C. And A is the geometric mean of Y and C. So let's write out an example of what this says. This says that H is equal to the square root of X times Y. This right here is saying that B is equal to the square root of XC. Okay? These three in a row.
And A equals the square root of Y times C.
And A is equal to the square root of Y times C. So if you have this set up, this one's certainly much easier, the first theorem. H is the geometric mean of X and Y. But this one's not too bad either. We start with the whole length here. If we multiply that by the little part here and take the square root, we'll get B. If we take this whole length here and multiply by that, take the square root, we'll get A. Let's do some problems, huh?
No, please.
Okay.
I'm lost.
All right. People in the class have requested a copying break. All right, we are going back into problems now. Nope. Okay. So let's look at this problem right here. We want to find x, y, and z, and this basically covers both theorems we just talked about. Okay? So Huh?
So when it signals down, you're gonna put it on that one so we can just rewatch it.
Yep. I don't think you will, but I am going to.
I have to.
Okay, so find x, y, and z. First of all, x is the easy one. X is our altitude. X is going to be the geometric mean of which two?
Of Y and Z.
No,
No, of 20 and 5.
20 and 5. X is the geometric mean of 20 and 5, or Jm and Mk. So 20 times 5, what is
100.
100? So what's x going to be?
10.
Hey.
Square root of 100 or 10? That was simple.
Yes. Yeah.
By the way, does anyone think we're about to run out of things we can do inside of a single triangle?
No.
No, not really. Honestly,
You could literally spend your whole life
What?
finding new things to figure out inside of triangles.
Just a question. What am I going to use triangles for in my life?
They're everywhere. They're everywhere. And reasoning skills.
Just triangle right there.
Okay? Okay. What about y?
Triangle right here.
What about y, everybody? Which theorem is going to help us find y?
X and 5.
No.
No. For Y?
5 and
5 and
5 and
25.
oh.
Remember, this whole length here is 25.
I multiply
And which one was the one in the middle? Y. Y is going to be in between 5 and 25. Okay?
So which one are we doing?
So we're doing y right now. We have to come up with this
For
whole...
which mean the hypotenuse or the...
We're trying to find y right here. And according to our second theorem we just did,
The leg?
this is in between this and that. So maybe if you're having trouble remembering this, probably thinking about it, which one is in between as far as lengths go? Y has to be in between 5 and 25. Okay? And then we just do the geometric mean.
10.
So Jm times Jk is 5 times 20. 5 times 25
125.
is 125. What's the square root of 125?
15. No.
No, it's close to 11.
No, it's like about
Well,
close to 30.
11 point something.
Think about it.
11 times 11 is 121.
12.
25 is a perfect square. What's the square root of 25?
5.
So the square root of 5 times 25
6.
is 125. Oh, I don't even think they're going to write it. So this is 25. The square root of 25 here is 5. So it's 5 times the square root of 5. Okay? 11.2.
Oh, that's crazy.
Okay?
That's why radicals are easier?
Okay, and finally, we want to find z. The picture and the question are on different parts of the slide. So z is going to be in between what two?
20 and 25.
20 and 25.
That.
Okay?
Why isn't it between Y and 5?
Because it's closer.
The way the theorem works, we're talking about this big triangle here. This one is going to be in between this whole length here and this partial length here.
Oh.
Okay? So,
You sure about that?
Yeah.
And then which one, right?
okay. So, z is going to be the square root of 20 times 25. What's 20 times 25?
500.
It is 500. It is going to be the square root of 500. Is there a perfect square in there?
500.
5 times 100. So 10 times the square root of, what did you say?
10 square root of 5.
10 square root of 5. So this, good job, should be the square root of 100 times the square root of 5. So that's 10 square root of 5. Or 22.4, which is between 20 and 25, right?
Square root of 5 is 2.24. And then we multiply both this.
See, I don't even, square root of 5, I haven't memorized
We
yet.
have them. We have to have them.
Yeah, I bet. All right, questions on this?
Knee slapper.
Did you also Wait, it's just random question.
Good job, Alex. You should read this already. No more keep fries.
Now we are going to practice what we have just done.
Oh no, come on, Mr. D.
Both of these triangles. If you guys can find x, y, and z in both of these triangles, then you're pretty good for this lesson. It's not hard.
Yes, it's hard, Mr. D.
Okay, and this is going to be the last of it for this class. So I am going to pause the video.